homesteading to prepping to common horse sense, we are College Hill Farm. Welcome back to College Hill Farm. This is Homestead Electricity Part 2. Well, last time we covered Ohm's Law and the power formula. That's just enough to start getting you into trouble about thinking about what it is you want to do on your homestead. Now, what we're going to talk about today, we're going to talk about a few different things, but mainly what we're going to talk about is something called kilowatt hours. Now, kilo means 1,000, so a kilowatt is 1,000 watts. Now, we learned how to calculate wattage in video 1. Now, if you haven't seen 1, you really ought to go back and watch Homestead Electricity Part 1, and that will help you understand what we're getting ready to discuss today. Now, your power company gives you electricity based on the number of kilowatt hours that you use every day. Now, each day you use a certain number of kilowatt hours, and that takes you over to the number of kilowatt hours that you use for a year. And electric companies charge you based on the number of kilowatt hours. And that means 1 kilowatt or 1,000 watts used for 1 hour. Does that make sense? When we start talking about solar systems and things like that, we also talk about kilowatt hours. So this will get you ready to start thinking about doing a solar type project. It'll also get you ready to start thinking about buying a homestead generator and how big a generator you need. You'll be able to use this video to go back, look at the things, the appliances, the things that you want to operate on your homestead in case of a power outage. Or if you want to operate them on your homestead and be off the grid with a solar system, this will get you toward the math that you're going to have to look at in order to be able to calculate how big a system you're going to need. Okay, so let's get at some of that math. Let's start talking about kilowatt hours. Okay, let's start off with our two formulas. Well, the first formula was Ohm's Law. Okay, it was volts, amps, ohms. Okay, then the other formula was the power formula, and I use these little diagrams to kind of help you lay it out without having to worry about knowing algebra. Okay, that's why I do this. It was watts, amps, and volts. Okay, these are the two formulas that you're going to need to use. But, do you ever remember your dad fussing at you? He said, "You're costing me a fortune, turn that light out." And he was worried about how much it was costing him to operate that 100-watt light bulb. He's always fussing about turning the lights out. Well, let's see what he meant by that. We've got a 100-watt light bulb. At 120 volts. I don't want to know how many amps it is. That's not important right at the minute, because I'm not trying to figure out how big a breaker I need. But I want to find out how much the electric company is going to charge me for that light bulb. Well, first off, electric companies charge by kilowatts. Okay? Kilowatts per hour. Or we call it kilowatt hours. Okay, that's the way the power company works it. Well, a 100-watt light bulb is not 1,000 watts, but it is if we move the decimal point 3 places, because how many zeros is in 1,000? 3. So we move the decimal point 3 places, that would be 0.100 kilowatts. Does that make sense? I just divided that by 1,000. That's 0.1 kilowatts. Well, if we left that on for 24 hours a day, all right, you forgot and left your dad's light on 24 hours. So if you multiply that out, that's 2.4 kilowatt hours. Does that make sense? That's 2.4 kilowatt hours. Now, if you look up on your power bill, for us, it's 0.0098 per kilowatt hour. That's how much it costs us. I'm sorry, I've got that decimal point in the wrong place. It was 9.8 cents. Okay, but if you do that in dollars, it's 0.098. Alright? It's 9.8 cents, but let's leave it in cents just for the heck of it. It's 9.8 cents per kilowatt hour. Well, how many kilowatt hours did we have? We had 2.4, so it would be 2.4 times 9.8 equals, get out my calculator, 2.4 times 9.8 equals 23.52 cents. So it didn't even cost a quarter to run that light bulb all day. Okay? But Dad might have a point because there's 30 days in a month. Okay, so you multiply that by 30. That's 705.6 cents. Or in other words, that light bulb cost you $7.06 a month to operate. Does that make sense? To burn it 24 hours a day, it costs $7.06 to operate. Now, let's do another one. Let's say you've got a heater. Get a clean sheet of paper. Let's say you've got a heater. It's a 1500 watt electric heater. It operates at 120 volts. Okay? But what's really important is it's 1500 watts. Now let's say that heater, out of every hour, it runs for 30 minutes. Okay? You don't have a whole lot of insulation, so the heater has to run every hour for 30 minutes. So in 24 hours, how long is that heater run if it runs every half hour? For a half an hour. Well, it's ran 12 hours. Does that make sense? That heater is actually ran 12 hours a day. It's actually running 12 hours a day. If it had ran for 15 minutes every hour, you divide that by 4 and it would run 6 hours a day. Does that make sense? So let's say that heater ran for half an hour for every hour. So it ran 12 hours a day. So it's 1.5 kilowatts. Why? Because it's 1,500 watts, so you just move the decimal point 3 places and makes it 1.5 kilowatts. And it's running for 12 hours. So if you multiply that out, (1.5) times 12 equals 18 kilowatt hours per day. So 30 days, you're going to run that heater for a month. That's 540 kilowatt hours per month. Now, 9 cents. So times 9.8 cents. And I think mine's going up to 10 something. But right now it's still 9.8. So 9.8 cents. That's 5,292 cents. Move the decimal point 2 places. That's $52.92 to operate that 1,500 watt heater for a month. Okay, so it's obvious now that if you put in more insulation and the heater runs 6 hours a day as opposed to 12 hours a day, you're going to cut your bill in half. Does that make sense? That's why insulation is so important. And that's the way they charge you for a kilowatt hour. Now, let's talk about a motor. Let's say you've got a motor and it is 1 horsepower. 1 horsepower is 746 watts. I've had people tell me before, and they would go, "Oh no, that fella used the saw and it made my electric go up so much. So much." Well, let's say you've got a carpenter and he's using a 1 horsepower motor on a saw. It's drawing 746 watts. So now the truth is that motor draws more wattage to start than that, but it's going to average out to 746 watts. So the motor is 746 watts. Let's say you've got a carpenter and he uses it every 10 minutes for a minute. Let's say he uses it 6 minutes out of every hour. Okay, so he's cutting board 6 minutes out of every hour, because it just takes 30 seconds to cut a board, so it doesn't take long. So he's using it 6 minutes out of every hour, and in 24 hours, 6 times 24, 6 times 24, he's used that at 144 minutes. How do you convert that to hours? Do you remember how many minutes are in an hour? So it's 144 divided by 60 minutes divided by 60 equals 2.4 hours. So that saw for that day was in operation only 2.4 hours. Okay? So there's 746 watts, so if you move the decimal points, that's 0.746 kilowatts. Okay? 7.46 kilowatts, there's only one L in kilo, but you get the idea. 7.746 kilowatts, and you're operating it for 2.4 hours. So if you multiply that out, 0.746 times 2.4 is 1.79 kilowatt hours times 9.8 cents it costs 17.5 cents to operate that saw for the day. Does that make sense to you? Okay? Now, I'm going to do a problem, and I want you to figure it out. You've got a freezer. You've got a freezer. It draws 1.7 amps. Okay? It runs 15 minutes out of every hour. How many kilowatt hours does it use? At 120 volts. It's got 120 volts. Got a freezer, 1.7 amps at 120 volts. It runs 15 minutes out of every hour. How many kilowatt hours does it use? Pause the video and work it out, and then we'll come back to you. Okay, we're back. We look at that. We've got 1.7 amps. We've got 120 volts, so we know the amps and the volts, but we need to know the watts so we can do kilowatt hours. So watts is amps times volts. So watts equals amps times volts. Well, if we do that, it's 1.7 times 120 equals, so 1.7 times 120 equals 204 watts. This is the exact same problem that we used in number 1. And it's actually, this is the amperage that my 7 cubic foot freezer draws. Okay? So this is all leading up to something about how you calculate what you need to operate on your homestead. So I've got 204 watts, or in other words, I've got 0.204 kilowatts. Now, it runs 15 minutes out of every hour. So, in other words, that's a fourth of an hour, right? So, every 4 hours, it's going to run a full hour. So, how many 4-hour periods are there? There are 6. So, that's 6 hours that freezer's going to run in a day. Does that make sense? It runs every 15 minutes. Every 4 hours it's run a full hour. So 4 goes into 24 6 times. So 6 hours. So the freezer itself will have run for 6 hours. So if you multiply that out, .204 times 6 equals 1.224 kilowatt hours per day times 30. And why do I use 30? Because that's a month. Times 30 is 36.72 kilowatt hours that freezer uses in a month. I need to break down and make me a camera set up just for this kind of stuff. But anyway, there's 36.72 kilowatt hours per month. Times 9.8 cents. If we do that, that gives us 359.8 cents. Or in other words, $3.60 per day. Per month. is what that freezer costs me to operate at my current energy rate. So you multiply that out for a year times 12, and that gives you $43.18. Wow, $43.18. $43.18. Can't write. So now, that freezer costs me $43.18 a month. If I've got 3 of them, or a year, I can figure out how much it costs me for a year. Now, I want to give you another problem and let you work it out. One more. All right. Your outdoor lights. You've got a barn and you want to set up a set of outdoor lights, and you've got a 300-watt outdoor light. It's going to be on 6 hours per night. At 10 cents per kilowatt hour, how much does the light cost to run a month? Pause the video and then come back and I'll work it out. Okay, welcome back. Well, 300 watts is 0.300 kilowatts times 6 hours. That winds up being 0.300 0.300 times 6 equals 1.8 kilowatt hours per day times 30. That's 54 kilowatt hours per month. Okay, so at 10 cents a kilowatt hour times 10 equals times 10, that's 540 cents, or in other words $5.40 is what your electric bill is going to go up. $5.40 is what your electric bill is going to go up for the month that you install that light. And it will go up that much every month that that light runs. Okay, does that help you figure out where your electric bill comes from? Okay, now let's talk about a solar panel. Let's say you want to install a solar panel and you've got a 1 kW solar array. Okay, a 1 kW solar array. Well, a 1 kilowatt, that means that as long as the sun's shining, that's putting out 1 kilowatt on the perfect day with the perfect sunlight. Okay, it's going to put out 1 kilowatt. Some put out a little bit more, but mostly no. 1 kilowatt is not an average. It's going to average somewhere in between, but we're going to stick with 1 kilowatt for the purpose of this. So I've got a 1 kilowatt solar array, but where I live, the sun's only going to be effective for about 8 hours a day in the winter. Okay, That's the most my solar array is going to be able to do. Or in other words, that solar array would only put out 8 kilowatt hours per day on a good day. Well, could I run my freezer on that? Well, first off, you have to be able to save it. And in order to save 8 kilowatt hours, you've got to have a battery sufficient to do that. And the scope of this is not to get us to how to set up your solar with the batteries. That's a whole different thing. But what we want to look at, let's say your solar generator can put out 8 kilowatt hours per day. Well, we go back to this 300 watt light bulb that we're using. Okay? It used 1.8 kilowatt hours per night, per day. Would that solar array be able to run that? The answer is yes. You'd have to save the energy. But know that when you save energy from a solar array, you're only going to be able to save about 50% of it. Okay? Because you have to save it, and it comes from the solar array in something called DC. Then it has to be changed over to AC, and there's losses going to the battery, being conserved into a battery, and then being pulled out of the battery. So really, in essence, this 1 kilowatt solar array is really only going to give you about 4 kilowatt hours worth of energy. Okay? So it would operate the light. 2 of those lights is 3.6 kilowatt hours. That would pretty much max out this 4K worth of savings that you have. Okay, does that make sense? You might be able to run 2 of these lights, but you might have to augment with a generator. This is a good way that you start looking at solar power. Let's go back to our freezer that we were talking about. And this is my freezer, and this is part about where we're going in the next set. We've got 36, let's see, how many kilowatt hours per day was it? It's 1.24. 1.224 was the freezer. It was 1.224 kilowatt hours per day. Could I run 2 of those freezers with this solar array? Well, that would be 2.448 kilowatt hours per day. My solar panel could generate 4, okay, that I could use. So yes, I could operate these 2 freezers if they only had to operate, okay, if they only had to operate, run for 6 hours a day. I could operate these 2 freezers on this 1 kW solar panel. Does that make sense? That's how you calculate this kind of thing. But you got to know that solar has to be saved. There's a 50% reduction in the amount of power you get back after you save it. Okay, and it could be even more depending on the batteries you're using. You want to use a really highly efficient battery that makes this 50%. If you just decide to use, let's say, a marine battery, a 12-volt marine battery to save and then convert it back, this is probably only going to be about 30%. Okay, you really want to have a really efficient battery. Now, this leads us up to the perfect generator. Okay, that gets us up to talking about the basic homestead generator. Now, what you want to do when you're talking about a generator is you want to look at what you need to run on your generator and figure out how many watts you're going to need, how many kilowatt hours maybe. But generally with a generator, generators are rated in watts. And you'll know that it costs a lot more to operate a manual generator than it does to buy electricity from the power company. It just does. That's just the way that works out. But this gets you the basic electricity to get you to that. Now, the next part of this is selecting the optimum generator for us. I'm going to show you how we decided on the generator that we needed to purchase and how we came to that conclusion. So that concludes part 2 of electricity, homestead electricity. Be certain to watch the third part, and it will help you to be able to figure out what type of generator you need, and you'll see what kind of generator that we bought and why we selected it. Now, if you like this kind of stuff, this homestead and do-it-yourself kind of thing, be certain to come on out to the channel and subscribe. We do this homestead stuff every week, sometimes 1, sometimes 5 videos. Just depends on what's going on in the homestead that week. Now, if you hit the little bell when you come to the channel, it'll notify you when we upload a video. We upload every Sunday. Now, with that being said, it's time for me to get on to the next thing.